Welcome to the OPI Lifecycle Working Group meeting for January 16th, 2024. I'm drawing a blank on what we should be talking about at the moment. It has been a long couple days for me. I know Dan has a proposal he wants to raise to the group, and I had a meeting with TSC last week, and we should probably hash that and discuss that as a group. Does anyone else have any items to discuss today, other than those two items?
I think we wanted to talk about the virtual AMC on the DPU card, the management controller.
Talk about the inherent challenges or difficulties in use of virtualized management controllers.
Yes.
That seems like definitely a relevant topic, maybe not one we should be talking about first, though.
Yeah, that's fine. We can put it in the queue.
Okay. So we have three topics. I know there's now a standing question regarding the if the PLDM chair or working group has acted upon the thread discussion. The request for additional states that we've made. Does anyone have an update on that? Raka, maybe? I guess not. Okay.
I think the document was still in draft when I checked last week. So
okay.
It was out for comment.
Okay, thank you. So in regards to the TSC, I guess that's a good first topic for today. My impression from the meeting I had last week, which I was summoned to, was basically that there's desire to see forward momentum and or forward momentum from the lifecycle working group. And naturally, I think there's probably some contextual disconnects that are occurring there. But I would like to see if people have thoughts and opinions regarding where we're at, where we're going, and what we should be doing or not doing. And we have crickets. So I guess, does everyone think we're on a good path or not a great path or unknown?
Yeah, I think maybe not that we're on a bad or wrong path. It's just that I think it would be good to, now it's a new year, kind of restate our purpose, is that we want to have a well-defined mechanism so that users can use multiple different types of devices from different vendors, and the vendors know exactly what they need to adhere to have that, provide that experience. So I think that's always been the goal of this working group, and I think we got in the weeds a little bit about trying to fix a particular issue with host boot. So I wonder if we could bring it back to, all right, well, how do we, how do we get back to that standard, just to get the lights turned on for each of these different types of devices.
Yeah, similar comments here. Maybe what we need to figure out is how do we make forward progress? I think we're on the right path. There are multiple threads that we need to run down, but holding ourselves accountable to some timeline seems to be the missing piece.
I think the challenge, and at least this is something that's resonated with me since I think someone in August pointed out that one of the things we're discussing is going to take multiple generations of silicon for their their employers' cards. So it's not an immediate thing we're going to see a return on. But it's definitely there's a consensus that's required to be reached before they can even start advocating that in the engineering process. So I think there's kind of both, and I think the challenge, especially with the boot stuff, is also if you're looking at it from the actual server vendor side of things, those are lots of very big questions that we've been discussing. And they're very pertinent to those vendors' cases because they have to support their customers too.
Yeah.
They can't just say you're not supported or in a supported configuration if something really weird goes sideways for them. So I think there's definitely a rabbit hole there. It's very easy for us to fall into that. And I think it's also a very valid one to kind of dig through.
Yeah, I would say kind of the challenge to this group compared to others is it's hard to produce like a standardized software API or library or anything like that, because most of this deals with hardware and vendor specific firmware, right? So it's more of we're trying to standardize what has to be developed by multiple different companies.
I definitely agree there. So that, I guess, hearing a couple of various statements, if anyone else has other thoughts and opinions here, I think it'd be good to share that. But if no one else does, Dan does have something you'd like to share with us. Dan, if you're still up for it. Otherwise, we can give Dan the floor.
Yeah, let me get off mute. I was trying to talk and pull up the document at the same time. It didn't work out very well. Okay. Yeah, so so Julia came to the TSC last week and said, do we want this or not? And I think I like I was saying earlier, I really want this standard so that we can all provision and have a common life cycle across all these devices. We can't even agree on what to call them, so let's call them devices. But I think we can get there. So let me pull up this document that I wrote, and this is I hope not scary. I wrote this to be lowest common denominator. And what I'll do, if this looks okay to folks, I will post this as a PR so we can do the normal review session. But I thought I'd bring it in here first so that if I had something just egregiously wrong, we could catch it. Just stop it from public embarrassment. So I'm calling a device here anything compatible with the specification. It could be a DPU, IPU, whatever. CPU probably. And establishing a baseline saying, all right, really what it means for this device to be applicable to have this specification applicable to it is that it's a PCIe endpoint that's PCIe compliant. And when it enumerates, it follows PCIe standards. You get a fixed set of PCIe devices. And if you want to modify that, then you use the mechanisms defined in the standard. And if you want the attached host to boot from that device, you have to be ready for the host to come up first, device comes up first, or they are at a race to the finish to be able to do boot. So put that in as a PCIe baseline, and then I have two sections on, it fits in one screen. Check that out. Two sections on trying to summarize the other pieces that we've been trying to work on in this group for a while is that in terms of BMC connectivity, we want to have some mechanism to be able to get the voltage and the temperature. And we want to be able to have some mechanism to get like the MAC address and things like that. And instead of sort of specifying all those little bits and pieces, I think that the consensus around folks that do this at Intel is that to specify NCSI control and monitoring, which is a subset of NCSI, so that you can get things like the MAC address. You don't need to support pass-through, although it's probably a good thing if your connectivity allows it, and we're not requiring that you have a special NCSI connector. You could go over the Goldfingers with SM bus, or if there's a USB going over your Goldfingers, that type of solution. And then the third piece is just tying in together.
Was that the NCSI 1.1 commands, or were you going to pull in 1.2 stuff? Or
that's a great question. We can be very specific here. I don't think it's a 1.2 thing. I don't think we'd want to specify that, but yeah, I'll double back on that. It'd be good to just call that out.
Yeah, I mean, yeah, what control and monitoring are you wanting? I think you can only get like the BMC MAC address, and I think you can monitor like packets and link state and things like that, but you can't.
Yep.
There's no thermal monitoring in 1.1. There's no.
That's right. That's why PLDM type 2 is for thermal and voltage, and then NCSI. Yeah, I'll just itemize them out because there's not a lot. It really is like BMC MAC address and link state, like you said. The types of things are out of there. So keep it real simple.
Yeah, but you wouldn't have pass through probably over SM bus, right?
No. That's why we said it's not required, because depending on the Goldfingers, SM bus will for sure be there, but whether or not VDM or USB is there seems unlikely to be a lowest common denominator.
Then I guess for me it's always like I want to see what's the use case that's driving the need for the NCSI.
The NCSI is good to get the MAC address. Is sort of like an identification, so that you can get the MAC address, and that potentially can tell you the other thing that in terms of lowest common denominator that we were wanting to get was some sort of device identification, so that if you were doing SCTP based on trying to figure out what card is in there. If you're trying to get the information from the card itself and not from a QR code or something, we wanted to get the identification somewhere. And so NCSI was like, okay, well, that's probably the best way to ID the card, because there's no standard like FRU mechanism. So that's 80% of why we
I guess double back on that, because I think the MAC address that you can get with 1.1 commands is just the BMC MAC address. I'm not sure you can get the factory MAC address for the channel, like what I'm saying, that would help you identify.
The uplinks, yeah, for the Ethernet. Yeah, that's interesting. Okay,
because it's kind of going the other direction, if that makes some sense, right?
Yeah, that makes sense. Yeah. Yeah,
it might help you identify the server you're in, but I don't know. Yeah,
that would be helpful, actually. Yeah, could be helpful. But yeah, the things that we're going for with NCSI are ID and link state.
Okay, link state definitely. But then, I mean, yeah, so there is also like the hardware snowflakiness of all these devices, right? And that NCSI assumes that there's one NCSI channel, there's a one-to-one relationship almost between channels and ports.
Mm-hmm.
And that relationship does not seem to always hold true with XPUs.
So that's why we
Some
need
people think of an XPU almost like a switch, right? So in that case, it doesn't, right? So anyway.
Yeah, and the goal here with this PCIe baseline and maybe the BMC connectivity, call it a baseline, is that we want the device to behave more like a NIC, because that's what these a NIC or a whatever, a storage controller, right? Behave more like
Yeah.
that than
Yeah,
'cause
classically, that's what a BMC can understand, right?
Yes,
It's never had
exactly.
to deal with a switch really. So
Yeah, a switch on a PCI card. Yeah, is not what we is not what is the lowest common denominator. So yeah.
okay,
In
right.
the NCSI over the Goldfingers, will the device need to send messages to the BMC? I'm thinking, I squared C, the path there through MUX is not always in place. What happens, and also what happens, or how does this work for multiple devices in the server?
Like I said, we should treat it like a NIC, right? So in that case, there is no, it's sort of unidirectional, right? The BMC is just detecting what's out there. They shouldn't expect to be getting any messages from the device that is not what you'd get from a
Yeah, that's why
or a storage card.
that's why pass through over SMBus is not really good. But yeah, the BMC always has to poll all the devices so that BMC sets up the muxes in the right direction and then sends request, gets a response, and moves on.
Well, let's.
So it's unidirectional and multiple devices can be supported. Okay.
Yeah, for sure. Yeah, we're not wanting to reinvent anything on the BMC side. That's probably even more expensive than the changing something on the IPU. So we don't want to do that. So, and then once you have that baseline, once you're connected in, BMC knows you're there, thinks you're a NIC, or it thinks you're a storage card, whatever, it doesn't matter. It can look at your temperature, look at your voltage to adjust the fans if it needs to, because this is a higher powered card than normal. That's winning in my book. And then once we have that, then we can layer on top the lifecycle management that we've already defined, where you get to the card using SCTP, get your telemetry through OTel. You can read stuff on the card with SMBIOS. These two things that I added that we haven't specified, but I think that we should, are things like setting up the security keys so that if you're going to be getting onto this machine through a script or something like that, through a orchestration tool, so you can't have passwords running around. So you need SSH and TLS, either pre-provisioned when you booted, or some other standard method, like treating it like a Linux system. And then we need some standard mechanisms of software update.
Wouldn't that be set up by ZDP, SCDP?
I think so. And if we wanted to say that is the way you do it, then I love that. It's just great. But we need to be explicit about it.
Well, I mean, the other way to do it, well, I mean, how you want to do the initial configuration. The other way to do it is to have that, Kickstart or Bootstrap image, right? So, SCDP gets you towards a one-time network boot, and then that one-time network boot has a bunch of run on first boot jobs that either you customize the image and put those keys in there, or they get
I don't think we need to specify that choice. I think that's just the choice of their software, but I think we just need to specify that you get in and out of the box using a secured channel. And so we just have to make that the default, so that you know, no one can use the OPI lifecycle mechanism and have an open backdoor card. So that's why I put that there. And same thing for software update, where whatever our software update mechanism is, I think we should be prescriptive about maybe not like what it is, but how it's done. That it's TLS, that's an RPC, that it's you need to have. There is no default trust involved. Like the trust has to be baked into your image that you've built, versus like, oh, I know on this channel with these little pins, I trust whatever's coming on these pins. Like, we can't have that. So that's why I put those two at the bottom. But I think that 80% of the lifecycle management stuff is already done in this group. So I feel comfortable there. I think we just need to make a statement on, I think we were getting we were saying, well, can we do software update from the BMC or things like that? It's like, sure you can, but it should use the same mechanism that any other entity that wants to connect to these devices would use. And it has to be secure. So those last two bullets is my editorializing on the first three, which I think we have really good, that's a good baseline to start.
Yeah, thanks, Dan. Maybe a quick comment. I think it's a good start in a sense that carving out or fleshing out the level of all different level of requirements that shall be supported, or it's already been supported with some of the references that you have included here. On the bullet 3 for the system information, I assume the SM bias will only be able to capture the local or system information locally from
That's
the
right.
devices, right?
Okay.
And then we had discussed a couple of other alternatives, maybe that you have already captured in the link itself. But just to name a few, I think it was the Redfish, right, that you can use for the remote query about the system information, and that the Redfish server can expose all that related information that it has been fetching locally from the system itself. I think that, I don't know if you have that in your mind, or what's your understanding on that?
I didn't list that out. I think that's a good point, though, is do we want to specify in the lifecycle management sort of a configuration runtime of your orchestration somewhere, and you want to figure out what's going on with that system? That gets right into maybe the OPI API world of things. So I didn't put it in there, thinking it was going to be a larger thing, but we should mark on that for sure.
Another comment: before provisioning, I assume there will be a bunch of manufacturing time steps, and I think I mentioned it in the previous discussions as well around the secure ZTP, the sequence diagram that we have. I think it's good enough in a sense that it captures the provisioning aspects, but I think there are certain activities or bunch of steps that needs to be executed during the manufacturing time itself, like maybe spooling in the certificates that is needed for the trust establishments, and
Right.
just to name a few, the
Yeah, and
SPDM
I
certificates and all those things.
That's why that's why I left these as just bullets. Like, hey, we defined SCTP. This on screen, and was meant to just be a breath first search when we're ready to. Okay, so my proposal here is that we we make a really high level spec like this and keep everything high level, and we get agreement and approval on that, and then we go and assign sub teams to do a depth first exhaustive search of each of the bullets to get all the details right, and then we'll have a spec that will be useful for users, useful for IP vendors and server vendors, like DPU, IPU vendors and server vendors. I think that's the approach I think we should take in this forum for the next several months.
Yeah.
Yeah.
I think one thing that would be helpful is to create defects or tasks and things like that inside of GitHub, so that we're breaking things down into small completable items that we track.
I love that. Yeah, let's use the issues list and just keep tracking it.
Yeah.
I love that. But I have a map of the world, to start, and then we're like, okay, this is cool, but you're missing a whole continent here, so let's add that, and then we go down piece by piece and flesh it out so that we can have something on the website and that people can start to refer to it. So we already in Intel, we already use there's like the SCTP and the OTel and the SMBIOS. We already use that to drive our how complete are we in terms of standards. So if we had a spec here, then it would be easier for us to drive to that.
Also, I think a while ago we discussed under lifecycle management, standardizing the actual XPU platform configuration. SMBIOS is kind of part of it. So it was the proposal to have a mechanism to verify what the DPU XPU configuration is in the right state, so it can run OS out of the box. It doesn't require any special fixes and stuff. So we kind of propose to have like open source tools like firmware test suite, and there are some other test tools which verify UEFI configuration and SMBIOS configuration and other stuff. So do you think we need to have here another bullet which say we will at least recommend how the XPU configuration can be standardized, XPU platform configuration can be standardized and can be verified?
Is that similar to what we were just talking about with Redfish and OpenConfig, or do you think that's separate?
It's I think it's separate with perspective from the platform. So in general, it's verification of the actual platform which runs the OS, and it's verification of the firmware BIOS and make sure it's in the right state to run the desired OS.
So, well, I guess my concern and challenge to the idea that we should have a standardized configuration that is applicable for everyone is, if you have, say, you have two competing vendors with different software stacks, their configuration is inherently going to be different from vendor A and vendor B. And I'm not sure we want to wade into the conflict that is their differing approaches and how their products are configured.
It's not really in configuration of the hard, like what kind of components they have on XPU. It's a matter of like there are no special needs to modify the OS to support all those configuration. We like in ARM we have our program which used to verify ARM based devices from different vendors to make sure what they follow the at least the same standard to allow to run the OS on the system without any special tweaks and stuff. So we already have that program, and we have a lot of open source tools which we use to verify that. And I think we, like a few months ago, maybe we had a proposal to see if some of those tools can be adopted, and some of the approaches what we use to standardize ARM platforms can be adopted. I don't know if you heard about System Ready, what we have.
I remember it being talked about. I remember a presentation. So you're not talking about the internal configuration of or the user configuration of the operating system. You're talking about the state configuration to get the operating system stood up and running.
Yes, exactly.
Okay, that's different. That's definitely very different. I think that's definitely an area that standardization is always better.
So we can propose, we can have more presentation to show what we have and see if we can, if it's possible, if we want to adopt it here in XPU and have some, I don't know, standardization on the platform level.
Okay.
What I'll do is, go ahead, sorry.
I guess my impression was that because, well, actually, until I take a step back here, I think the challenge that we have is we run a risk of also forcing a standardization that some vendors have already pushed back upon. So we also risk alienating potential points of engagement if we start saying you'll run this tool for this architecture this way. So I think that's, maybe this is an area that we should encourage, but not necessarily standardize upon. I'm not 100% sure that's a path we necessarily should take.
It may not be standard. It may be at least at this point, but we can provide a mechanism to the XPU vendors to actually test their devices and see what we expecting and what they have, and maybe they may have keep in mind what this is the areas where they can improve stuff. Or
absolutely.
Okay. What I'll do is I'll put a placeholder in another section. It's not in lifecycle management. It's more of a platform configuration section. And as we work through this spec and we can build enough consensus on that one, probably look really similar to lifecycle management, where we're saying platform configuration is done using System Ready, right? For example, that could be where we land. So, but if we can't build the consensus, then we'll drop it so that we can get the rest done.
So I do have a question, and I'm going to predicate this question with the fact that I have very little knowledge of how PCI works at lowest level. But we've hung up on device enumeration in the past because, well, basically some devices we know are out there are not compliant or are not compliant until they're running an operating system. So I think that the question I would wonder is, does the baseline force, does that stated baseline force a certain approach to PCI bus engagement for the device in terms of how it's operating, and if we have to hold enumeration, or if enumeration can just be done on power on?
Well, I mean, I put this in here to specifically address that issue, is that we must have run around for like a year with like 4 or 5 different proposals on how to get around devices that aren't PCIe compliant. And I think at this point, it's become clear that, I don't think we're going to, I don't think we're going to land at something that's going to be ready faster than fixing the devices that are not PCIe compliant. So, I I don't think it's I think that this is the do nothing baseline, right? Is like, all right, we're just going to assume that everything is PCIe compliant, and that, you know, if you want to boot from the host, then you have to be compatible with the existing host boot options, and we can move on, right? Instead of trying to invent some sort of mechanism to, you know, okay, you wait here and then you go, but then you have to wait. And like it's not probably the role of this group to go in and be inventing things to start. I think we need to figure out where do we, you know, where do we grab something existing like PCI or PLDM or SCTP and you know, find that lowest common denominator. And um, I I I think that we can get good agreement that being PCIe compliant is a reasonable starting point for a life cycle spec, when sort of the defining feature of these devices is that they slot into a PCI, versus, you know, being a smart switch or being an appliance or a switch or things like that. So that's where I started, and I did this specifically because we spent way too much time trying to uh, you know, fix a particular issue. And, you know, our answers were like, well, we have to go to DMTF and create a brand new spec. It's like, that doesn't seem like like you know, it seems like pushing the problem around than just you know, trying to make progress.
So Dan, first of all, thank you very much for putting this together. I think it's very useful. It's very good framework. And this particular issue of, you know, working around non-compliant devices, what you're proposing here is for devices that are compliant or devices that will be compliant in the future. And so I think you're raising the point in terms of how much effort should we put into a stopgap measure for those devices that are not compliant, right? And valid, very valid comment in terms of we spent a lot of time trying to work around non-compliancy. So yeah, I think we made some headway, and we need to continue making headway in the non-compliant stuff, but it's time that we really move ahead with things that will be compliant. So thanks for putting this together.
Because I think what will happen inevitably, I worked at these companies before a long time, is that we say, well, we have this bug, but, you know, it's on 100 on the list, and, you know, OPI worked around it, so we probably don't need to worry about it, right? But as opposed to, well, there's a spec out there, you know, we match everything except we have a timing race at boot up. We can fix this in, you know, and here's the literature out there on how OPI proposes you can fix this for your device. I think that would just be, that would be so much better for the industry than having to create a new spec that will again have an adoption rate where every component in that handshake or whatever has to go adopt it now. It just you know, this is going to give those users that just simpler have simpler expectations as to, okay, well, it's gonna kind of work like a NIC until I put some software on there, right? It will make it easier for people to get these cards running.
So how is what we're discussing on 2 different than 4, right? Like if we separate the device's power domain from the host, right? Then if it's a problem of timing, right? Are you talking about PCIe compliance other than timing?
Yeah, I was saying it's like a PCIe compliant endpoint. That's all. So I'm not specifying that you have to have split power, which will not happen, right? In standard servers, you know, I'm not specifying anything like that. I'm saying that you have to be an endpoint, and if that endpoint is meant to have bootable devices to make your system work, then they have to be resilient to the fact that, you know, these devices have different boot times. And, you know, we've posted several like industry standard solutions to this race condition. So it's a solved problem. So you
So
know,
if you're doing NVMe emulation, right,
mhm.
and you're booting from it, what's the industry standard solution for that? Like, is it you present an NVMe device that you don't yet have the contents for, or how do you deal with that?
Yeah, the NVMe spec offers a ready bit, that tells the driver to wait until the NVMe device is ready. And in this case, it's a emulated device, so it has to get, you know, end to end, got to reach back to where that disk is, and so that ready bit controls the controls the host UEFI, so that the UEFI doesn't go and try to read on a disk that isn't attached to anything yet. So NVMe has a bit. A couple of the other uh, hardware-based drivers like IDPF have a bit, and then in VirtIO, there are VirtIO drivers out there that know to wait on a bit until the VirtIO block or SCSI device is ready, or the VirtIO net, so that you don't PXE boot off of a net device that isn't ready.
Okay.
So that was one of the 4 or 5 solutions we posted probably 6 months ago. And you know, this is a solvable problem. So it doesn't require people to change their BMCs and their UEFI drivers and their server power, all these things. We don't need all that. We just need a bit that says, are you ready or not? And
So is the UEFI behavior though standard, like that
yeah,
UEFI will hold indefinitely if you give it
yes.
if the not ready bit comes back to the driver?
Yes, yeah. So if it's a standard driver that's in the UEFI image, then like NVMe, then it uses the standard NVMe bit. If it's a VirtIO driver that needs to block on that bit, the driver comes from the option ROM. So then you have to have an option ROM image that knows to look at the bit, and you're good to go. So, and if you had like a custom driver, like my custom driver for my device, that UEFI needs to load, loads it through the option ROM, and then it just needs to have its own ready bit mechanism between the driver and the device to make sure it's ready.
So going back to your earlier comment, if this seems scary, honestly, it doesn't seem scary at all. It seems fairly straightforward. I think obviously some folks are probably gonna have to think about it, ponder it, and come back and discuss further. So maybe we should do that. Plan on revisiting this on next Tuesday and discussing further and seeing if there are any other questions or concerns to discuss. And I guess in the meantime, you said you were going to work on making this request.
Yep, I will.
Perfect. Yeah, awesome. I guess this also all predicates upon having some sort of management controller pass through potentially.
What do you mean management controller pass through?
I guess management controller on the device itself.
Yes, yes, for sure. Yeah.
Yeah.
So this is the center of the universe is the device itself. And so it's in that respect, it looks more like a switch or appliance or something like that. But what we want to specify here is that when you have done nothing to that device, you put it in your PCI, it should look like a NIC or a storage controller. Only when you go and SCTP a new image on it and know its IP address and things like that, does it, blossom into an appliance or a storage into a switch. So you want to have that, coming of age moment. And at that point, its IP address, it's its own entity. And then I will add the sections on the Redfish, the open config, and then I'll add another section for platform configuration. And these are the parts that are really centered around, okay, well, this is its own thing, so it has to, how do we make these independent things that are not NICs, not just NICs, and they're not switches, how to make them standard. So I'll add that. I'll add those sections to PR, and then we can go back and forth through the tool once those are there.
Awesome. So I guess one of the topics that we kind of brushed up against last week, a week before, and then we kind of briefly hit upon earlier also was relation to virtualized management controllers. I guess in your concept, you almost need a hardware management controller.
Yeah, I don't know about hardware management controller. It's just it has an OS. It has an operating system. So
yeah,
I want to avoid the argument of do these devices require BMCs or not. I don't think we need to specify that, because I think that
my one concern is a lot of stuff we've gone deep into the weeds about in terms of what like chassis vendors, server vendors expect in terms of interactions to make their systems bootable with these cards in them would require basically hardware. I'll use term management controllers. They'll require management controllers that are online and working. And I think the challenge is if they're virtual machine running in the OS on the device, then it's kind of
yeah, that won't work.
yeah. Yeah,
it doesn't work. Yeah. I don't. That's definitely a rabbit hole for sure. So yeah. But
yeah.
Let's think about what the problem they're trying to solve with that is, and then let's approach it from there. So,
well, and this is, we're starting to dive into something completely separate from what you're presenting, but my impression is it's much more of a mental checkbox for someone buying the device. It's like, oh yes, you have some sort of out-of-band access without the full understanding of what people actually expect for out-of-band management access. Sort of, right. I think that's kind of the disconnect that exists. So I'd almost like to see us mandate something. Not necessarily mandate the mechanism or means. You can expose in many different ways. There are standards here for this sort of thing. Yeah. It's just that something has to be defined there. Right. And we need that sort of standardized approach. Otherwise, we're just going to create a world of hurt for the hardware vendors that have to integrate these cards into their server products and ship them.
Well, we get pretty far with SCTP. Right, so that gets you the IP address. You can that you can reach that system at that point. You can associate the security keys with that device at that point. So that does help you avoid a lot of the reasons why we have out-of-band management kind of go away, unless you did SCTP over out-of-band management, which is perfectly fine as well. So, like, depending on which network you run your SCTP on, then that determines how you access that device. Like, if you put the SCTP on the fast path, you probably did that eyes wide open. So, yeah. All right. So Yeah, this is just the approach of let's start from the top and then we can drill down and be able to. I like tracking the issues on the site so that people can see what other people are working on and can go reach out, and yeah, well, we can just kick off this for the new year.
Do we have any other topics to discuss today? I will take silence as a no. Thank you, everyone, for a great meeting.
Thank you. Good discussion. Thanks.
Thanks all. Bye.
Bye.
Thank you all.
Yeah, what Dan said makes perfect sense.